In this video, we are going to be reviewing trigonometry from Unit 6, trigonometry. Before we get started on a few of the practice problems from the remediation assignment, I'm going to go over the 3 trigonometric ratios that we do need to know to be able to do these problems. You'll remember those are sine, cosine, and tangent. So these represent 3 different ratios. Sine is the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent side. So for each one of these problems from the remediation assignment, we'll be going over the steps for each one of these so you can see how these ratios are used. So the first thing that we are going to do is just find the value of different trigonometric ratios. From this section, we'll be doing number 1 and number 4. So the first thing that you'll notice is that on number 1, we're wanting to find the tangent of C. So we're always going to be referencing a specific angle when we are doing trigonometry problems. So the first step is just to circle the angle that we're going to be looking at. So tangent of C, so I circled angle C there. And then I'm going to label my 3 sides. So we have our opposite side, our adjacent side, and our hypotenuse. I like to start by labeling the hypotenuse first. That's going to be the side that is directly across from the right angle. So my hypotenuse is there. Next, I'm going to label the opposite side. That is directly across or opposite the angle that we circled. So my opposite side is there. And last, I'm going to label my adjacent side. That's going to be the last side that we have left. That's going to be right next to the angle that we've circled. So tangent, if we look back here, tangent is going to be opposite over adjacent. And the way that we can remember all 3 of those is by using SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So with reference to C, I've got my opposite side and I've got my adjacent side. So I can say that tangent of C is equal to 20 over 15. Always double check because we're not quite done yet. We want to simplify if possible. So 20 over 15 can be simplified. Those are both divisible by 5. So I'm going to rewrite this as tangent of C is equal to 4 over 3. And that's my final answer. So we can walk through the next one a little bit quicker. We're finding sine of Z. So I'm circling angle Z. I'm labeling my hypotenuse first, directly across from the right angle. Then I'm labeling my opposite side, directly across from the angle that I circled. And then my adjacent side is the last side. So I'm finding sine. Sine is opposite over hypotenuse. So I've got my opposite side and my hypotenuse. So I'll end up with sine of Z is equal to 36 over 39. Again, you want to check, is this fraction in simplest form? It's not. These are both divisible by 3. So if I divide both the numerator and the denominator by 3, I'll end up with sine of Z equals 12 over 13. The next thing that we're going to look at is finding the missing side. So if we are given one angle and one side, we can find another side of a right triangle using trigonometry. We'll be doing number 5 and number 8 from this section here. And I want to make sure that I have SOHCAHTOA written somewhere on my page so I can reference it when I need it later. The beginning steps are about the same. Only one angle is going to be labeled here. That's this guy, and that's the one I'm going to circle. From there, I'm going to label all 3 of my sides just like I did last time, starting with the hypotenuse, directly across from the right angle. My opposite side directly across from the angle that I circled. And then my adjacent side right over there, my third side. This one's a little bit different because you don't know yet which trigonometric ratio that you need to use, if you need to use sine or cosine or tangent. So that's something that we need to figure out. And the way that we're going to do that is we're going to look at which 2 of our sides are labeled. So you'll see our opposite side, that's been labeled with a length of 20. Our hypotenuse, that's been labeled with x, that means that's what we need to solve for. But the adjacent side, there's nothing there, there's no length labeled, so we can ignore that side. So we know that we're going to need to use the opposite side and the hypotenuse to solve. So we're going to look over here at our SOHCAHTOA, and I see O and H. Looks like we're going to be using sine. So now I can set this up. Sine of the angle always goes right here. 25 degrees is equal to opposite, which is 20, over hypotenuse, which is x. So that's our setup. The next step is to actually solve for x. So the way that I'm going to do that is I'm going to first multiply both sides by x. What that's going to do is get rid of it in the denominator of our fraction over here. So what we'll end up with after doing this is x times sine of 25 is equal to 20. But we still don't have x quite by itself yet, so we do need to do one more step to get x by itself. And we're going to divide the whole side by sine of 25 degrees. Remember, anything that we do to one side, we do have to do to the other side. So that gets rid of all of this and leaves x by itself. So we end up with x is equal to 20 over sine of 25 degrees. Now once you have x on its own side over here, everything on the other side you can just plug right into your calculator, which is what you're going to want to do next. Before you do that, double check your settings and make sure that your calculator is in degree mode, DEG, and not radians, RAD. And then you can type it in just like that, 20 divided by sine of 25. Hit enter, and we can see that this side, rounded to the nearest tenth, is 47.3. All right, let's take a look at number 8. We're going to start off exactly the same. I'm going to circle this angle here because that's the one that's labeled. I'm going to label my 3 sides. I've got my hypotenuse directly across from my right angle. I've got my opposite side directly across from the angle that I circled. And then I've got my third side, that's my adjacent side. Next, I'm going to figure out which one of these 3 ratios I'm going to use. So to do that, I'm going to circle the labeled sides. So here I'm circling the hypotenuse because that's been labeled with a length of 18. I'm also going to circle my adjacent side because that's where my x is that we need to solve for. And then we're going to ignore the opposite side because there is nothing labeled on that side in the problem. So I need to use the adjacent side and the hypotenuse. So that means we're going to be using cosine, adjacent over hypotenuse, and now I can set it up. Cosine of the angle is equal to x over 18. So you'll notice in the first problem we did, when we set it up, the variable was on the bottom in the denominator of our fraction. And this time when we set it up, our variable was in the top in the numerator of our fraction. This makes it a little bit different to solve, but either way, we are going to take our first step by multiplying both sides by what's on the bottom in the denominator of our fraction. So what happens over here is those 18s will cancel each other out, and we'll end up with 18 times cosine of 74 degrees equals x. So this one was a little bit less work than on number 5. We've already got x on its own side, and we can plug this right into our calculators. So I'm going to put in 18 times cosine of 74 and hit enter. And I can see that this side has a length of, when we round to the nearest tenth, of 5. So that is how we find a missing side when we've been given one angle and one other side. We can also use trigonometry to find a missing angle when we've been given two sides of a right triangle. So again, make sure that you have SOHCAHTOA written on the top of your page or somewhere else where you can see it. And we are going to get started. We will do number 11 and number 14 in this section. The first step to solving these ones is the same as everything we've been doing. We circle our angle, and then we label our three sides. This time, though, the angle is what we need to be solving for, and that'll be labeled for us. Then I'm going to label my hypotenuse right across from the right angle, right there. My opposite side directly across from the angle that I circled, and then my adjacent side. Just like when we were solving for a missing side, we don't know what trigonometric ratio that we are going to use yet, so we have to figure that out. I know we're going to be using the hypotenuse because that's labeled with a length of 21, and I know I'm going to be using the adjacent side because that's labeled with a length of 9, and I know I'm not going to be using that opposite side because it does not have a length that's been given to us. Now I can set it up. So we're going to be using cosine here, adjacent and hypotenuse. Remember when we set this up, inside our parentheses here is always the angle. But since we don't know the angle, I'm just going to put an x right there. And then equals adjacent over hypotenuse, so 9 over 21. You don't need to worry about simplifying this fraction here, but we do need to figure out how we are going to get the x out from inside of this cosine function. And the way that we're going to do that is by using inverse trigonometry. So sine, cosine, and tangent all have inverses. Just like multiplication is the inverse of division and subtraction is the inverse of addition. The inverse of sine is just called inverse sine, and it looks like that. Inverse of cosine is inverse cosine. Inverse of tangent is inverse tangent. Remember, anything we do to one side, we do have to do to the other side. So I'm going to give us a little bit of room here so that we can do the inverse cosine of both sides. So what ends up happening here is the inverse cosine and the cosine cancel each other out, and we're left with x is equal to the inverse cosine of 9 over 21. And then you can take that, since we've got x on its own side, we can plug that in right into our calculators. So I'm going to put in inverse cosine, 9 divided by 21. Hit enter, and we can see that this angle, rounded to the nearest tenth, is going to be 64.6 degrees. So let's take a look at number 14 now. Following those same steps, circle the angle, label my three sides. I've got my hypotenuse here, I've got my opposite side here, and I've got my adjacent side here. I know we're going to be using the opposite side and the adjacent side because those are the two that have lengths associated with those sides. Since I am using opposite and adjacent, I know that means I will be using tangent for this particular problem. So now that we know about inverse trigonometric functions, we can sort of jump right ahead setting this up, and I can just say x is equal to the inverse tangent of opposite over adjacent. So it's the same thing that we did before, except we're just sort of skipping that initial step and jumping right here, where we can plug in inverse tangent of 10 divided by 28 in our calculators. And you should see that this angle is rounded to the nearest tenth, 19.7 degrees. Alright, so we've talked about the ratios. We've talked about how you find a missing side when you're given one angle and one side. And we figured out how to find an angle when we've been given two sides of a right triangle. The next thing that we're going to look at doing is solving word problems associated with trigonometry. So here we'll be looking at number 15 and number 16. So the first thing that you want to do with all of these is draw a picture. We know for these that we're going to be working with right triangles because we need to use trigonometry to solve them. So the first thing that I am going to do is just draw a right triangle. I'm just going to have that ready to go so I can label it. So now I'm going to look over the problem. A tree casts a shadow that is 6 meters long. Well, I know that a tree stands right up, so the tree is probably going to be right here. And the shadow lays flat on the ground, so I know the shadow is going to be right there. And my shadow has a length of 6. The angle of elevation to the top of the tree is 28 degrees. So remember that the angle of elevation, you can imagine that as being a horizontal line and then looking upward. So our angle of elevation is going to be right there. That's going to be 28 degrees. And then it asks us, how tall is the tree? Well, we talked earlier when we read this first sentence that the tree would have to be right there. So I'm just going to put an X there because I know that's what we're going to be solving for. Now I see that I have an angle labeled, I have a side labeled, and then I have my variable on another side. So this is enough information to get started. Now I can take a look at this triangle and solve it just like we did with previous problems. Circle my angle, label my hypotenuse across from the right angle, my opposite side, and my adjacent side. You want to make sure that you have your SOHCAHTOA written out there so that you can reference it. When I do this, I know I'm going to be using the opposite side because that's where my variable is, and I know I'm going to be using my adjacent side because that's been labeled with a value, And I know I'm not going to be using the hypotenuse because there's nothing on that side. So using the opposite and adjacent, that's going to be right here, going to be using tangent. So tangent of the angle always goes inside, 28 degrees, is equal to opposite over adjacent, that is x over 6. We're going to solve this just like we did the problems on this page here. I'm going to multiply both sides by 6, and that will leave me with 6 times tangent of 28 degrees is equal to x. So I'm going to plug that right in. 6 times tangent of 28. And I end up with x is equal to, rounded to the nearest tenth, 3.2. Make sure you're including your units here because it is a word problem. We are working with meters. So I'm going to say that x is equal to 3.2 meters. All right, let's move on to the next one here. So first step, just like the last one, I'm going to draw a right triangle. Just like that. So a person standing on top of a cliff sees a house at an angle of depression of 27 degrees. So the angle of depression is a little bit different. Remember that it is between a horizontal and looking down. So that would mean that the angle of depression is right here. Well, it doesn't really help us much because that's not actually a part of our triangle. It's sort of just outside of our triangle. But what we can remember that's important to know is that the angle of depression is congruent to the angle of elevation. So since those two things are congruent, if this is 27 degrees, then this is also 27 degrees. And now I have an angle labeled that's actually part of my triangle that I just drew, and I can move forward with the rest of it. So we have a person standing on top of a cliff. Our person's up here. I imagine this is our cliff here. The cliff is 100 meters tall, so I'm going to label that as 100. Since the person's looking at our house, imagine our house is right there. How far is the house from the base of the cliff? So base, meaning the bottom of our cliff, is right there. To the house, that's the side we are looking to solve for. So I'm actually going to redraw this triangle to make it a little bit easier to see what's going on, just labeling the important stuff. All right, and now I can follow the steps that I've been doing before. Circle my angle, label my sides. I know that I'm going to need to use my opposite side and my adjacent side, because those are the ones that have been labeled with values. My hypotenuse has not. So again, just like in the previous problem, we are going to be using tangent. So tangent of the angle, 27 degrees, is equal to opposite over adjacent, 100 over x. So this one's a little bit different because this time our variable is on the bottom of our fraction in the denominator. So I'm going to multiply both sides by x first. So I will end up with x times tangent of 27 degrees equals 100. Divide both sides by tangent of 27 degrees. So those cancel out right there, and I'll end up with x is equal to 100 over tangent of 27 degrees. I've got x on its own side, so I'm ready to plug this into my calculator. So 100 divided by tangent of 27. So this is going to be rounded to the nearest tenth, 196.3. Make sure you include your units, so it looks like we're dealing with meters again. All right, so the last thing that we are going to go over is these graphing problems here. So we're going to just go over number 19. So 2 points are graphed on each graph below. You can see that there and there. We want to calculate the angle between the line right here and the positive x-axis that's right here. So we want to make a right triangle. The way we're going to do that is we're going to go straight over along that positive x-axis, and we're going to go straight up. If you can draw straight lines, then you should have made a right triangle right there. Calculate the angle between the line and the positive x-axis. So between this line here and between right here, that is the angle that we want to be solving for. We can figure out two of the side lengths pretty easily because this part of our triangle is perfectly horizontal and this side of our triangle is perfectly vertical. So I know that this side has a length of 2 and this side has a length of 1, 2, 3, 4. I'm going to actually redraw my triangle over here so you can see a little bit better what's going on. As I label my sides, make sure you have this written down somewhere where you can see it. I'm going to circle my angle. I'm going to label my hypotenuse, my opposite side, and my adjacent side. I can see that I'm going to be using my opposite and my adjacent side because those are the two sides that have been labeled with values. Since I'm using opposite and adjacent, I know I'm going to be using tangent to solve this problem. So I can now set it up. Tangent of x is equal to opposite over adjacent, 4 over 2. Well, I'm solving for the angle here, so I know that what I need to do is use the inverse tangent. So I'm going to rewrite this as inverse tangent of 4 over 2 is equal to my angle. I can just plug that right into my calculator. Inverse tangent, 4 over 2. So rounded to the nearest tenth, my angle is going to be equal to 63.4 degrees.